Hi students, welcome to today's class. In the last few classes onwards, I am teaching about circles, straight lines and a pair of straight lines and also parabola also completed. I have discussed a few problems on parabola. Now I am switched on to the new chapter, that is ellipse. So ellipse is also a very important chapter and you are getting one problem from the chapter ellipse. Of course, in the JEE mains level, you will get a mixed problems, parabola, ellipse, hyperbola, the mixed type of problems you will get. But in particular, ellipse is a very important chapter. Okay, so if you understand ellipse, next chapter is hyperbola. Those concepts are also almost related to ellipse. That's why keep concentrate on this chapter, ellipse chapter. Okay, so in our day-to-day life, we have seen so many elliptical shape of objects. The best example is egg. Egg is also in the ellipse shape. That means this type of shape is called, generally we call it as ellipse. So what is ellipse? What is how we define mathematically ellipse? So if you go for in the previous classes about the eccentricity, let us take S is a fixed point in the plane. Let S is a fixed point in a plane and a fixed line L is equal to 0 is a fixed line. Both are fixed, point and the line both are fixed. Let P is a variable point, P x comma y is a variable point. Variable point means it is moving that side, this side like anything, such that the ratio of the distance between the S and P and the P at P to the line M. That means the ratio of the distance of the point to the fixed line and point to the line. That is a SP by PM, we call it as a eccentricity. So this we are denoting with the letter E. In the previous chapter, it is a parabola. If E is equal to 1, then the shape of the locus is named as parabola. If E is first point 0 less than E less than 1, then the name of the locus is ellipse. Whatever may be the curve traced by the point P x comma y, that curve name is given as ellipse shape. Okay now? So now coming to if a general second degree non-homogeneous equation. What is general second degree non-homogeneous equation? So I am writing general second degree non-homogeneous equation. What is second degree non-homogeneous equation means? This is the second degree of in the variables x and y. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is a non-homogeneous second degree general equation. This equation represents a curve when delta is not equal to 0 and h square minus ab is less than 0. Now again, what is delta? Delta is nothing but abc plus 2fgh minus af square minus bg square minus ch square is not equal to 0. What are these a, b, c, f, g, h? They are all coefficients of x square, y square, x, y, x and y variables. Okay now. So the value ABC plus 2fgh minus af square minus bg square minus h square should not be equal to 0 and the value of h square minus ab should be less than 0. h square minus ab is less than 0. Okay. If these two conditions are satisfied, these two conditions are satisfied, then the second degree non-homogeneous equations in the variable x and y, namely ax square plus 2hxy plus by square plus 2gx plus 2f plus c is equal to 0 represents a curve whose name is ellipse. Okay na? Right. So the first thing what you have to learn from this is the eccentricity is less than 1. Of course, it is greater than 0, positive value. Why? Because always eccentricity means it is the ratio of the two distances. So distance is always a positive quantity. So therefore 0 less than E less than 1. So less than 1. So first thing is we have to remember is the eccentricity of the ellipse is less than 1, and a general second degree non-homogeneous represents an ellipse if and only if delta not equal to 0 and h square minus ab less than 0. Okay na? Right. I hope that up to this you understand this. Now we are going to see what is general equation of an ellipse. Okay na? Let us see the standard equation of the ellipse. Okay na? Right. So here it is a x-axis. Let us take the x-axis, and it is a y-axis. Okay. Let us take the center of the ellipse coincides with the origin. Center of the ellipse coincides with the origin. So that is equal to, so this is a center of the ellipse, and you will have two foci. So this is equal to S, and it is S dash, and you have two vertices, and it is a and it is a dash, two vertices A and A dash, and you have two directrices. So this is equal to one directrix, and this is equal to another directrix. Okay na? So this is equal to Z, and it is Z dash, Z and Z dash. Okay na? So there are one center, two foci, two vertices, and two directrix, and Z and Z dash are the foot of the perpendiculars from the center to the directrix. Okay. Let the distance between, here you will get a two axis, that is a dash, and we call it as a b dash. Here A and A dash is called major axis, and b dash is called minor axis. That is, the ellipse is symmetric about both x-axis and y-axis. Okay na? That is the first point you remember. Let the distance between the center to the any vertex be A. CA is equal to A, and CB is equal to B. That is, this length is equal to A and this length B. That is, CA length is A and CB length is B. Then the equation of the ellipse is x square by a square plus y square by b square is equal to 1. Now we are going to establish a relation between A and B. So here A is a semi-major axis, B is a semi-minor axis. Okay. So we are going to get a relation between A and B. So that is given by the relation E is equal to under square root of A square minus B square by A square. E is equal to square root of A square minus B square by A square. That is the eccentricity of the ellipse. Okay now. This relation also can be remembered as, so squaring on both sides you see here, E square A square is equal to A square minus B square. So let us take B square to left hand side. B square is equal to A square into 1 minus E square. So this is the relation between, so E square is equal to A square minus B square by A square. Cross multiplication, E square A square is equal to A square minus B square. Take minus B to left hand side, to A square that side, 1 minus E square. So this is a relation between A and B. Okay. Right. Now we are going to see all the coordinates of the points C, 2 foci, and points of the major axis and points of the minor axis Z and Z dash, and equations of the major axis, minor axis, and focal chord, double ordinate, directrix, all those things we are going to see. Okay now? Welcome back here. So here the standard form of the ellipse is x square by A square plus y square by B square is equal to 1. where A greater than B. Then how to remember all the points? Or systematically you remember. So this whole picture it should be in your mind. Starting from the center, first learn center C, next S, next A, next Z, B. This is the 5 points we have. One is C, S, A, Z, B. Those are the 5 points we have. All the coordinates of those 5 points we should know. And particular this also, that is L, L dash, end points of the lattice rectangle. First, the coordinates of the points you should know. The first one is C is called center. Center is equal to 0, 0. Center is C, only one center, 0, 0. Second one is foci. Foci means S, S dash. So this is a S and it is S dash. Foci is a plus or minus AE, 0. Plus AE, 0, which lies on the right side, minus AE, 0, which lies in the left side of the center. Okay, na? C is over. Next, go forward. A. Those are called vertices. Vertices means here A dash. This is given by the formula plus or minus A, 0. So this is a 0. This is minus A, 0. Next, go to Z. Z dash. So Z and Z dash are called foot of the perpendicular from center to the directrix. Center to the Z directrix. That is given by the formula plus or minus A by E, 0. That means to the right side. So this is a Z coordinates are A by E, 0. This side Z dash. So this is a Z and it's a Z dash. These coordinates are minus A by E, 0, like that. Next one, lattice rectum. All these definitions already I explained about what is the lattice rectum. So what are maybe lattice rectum definitions are in the parabola. Here also the same definitions. What is the lattice rectum? It is a focal chord perpendicular to the axis of the ellipse. Okay. Now end points of the lattice rectum, that is a L, L dash. This is given by the formula plus or minus B square by A, sorry, plus or minus AE, comma B square by A. Right, 2B square by A. So plus or minus AE, comma B square by A. So only B square by A only. Why? Because length of the lattice rectum is 2B square by A. That's why L coordinates are plus or minus. This is also plus or minus B square by A. Why? Because there is another lattice rectum will be there here also, L and L dash. Altogether you will get 4 points. 1, 2, 3, 4. Those are the end points of the lattice rectum, that is a plus or minus AE, comma plus or minus B square by A. So plus plus minus minus plus minus minus plus, altogether you will get 4 points. So this is L is called positive end of the lattice rectum. L dash is called negative end of the lattice rectum. So this L is lies in the first quadrant, that also you will know. So if the end point of the lattice rectum lies in the first quadrant, its coordinates are AE, comma plus B square by A. Okay, now next one. So all the coordinates again B dash, that is the end points of the major axis, sorry, minor axis. That is equal to B, and B dash is given by the formula 0, comma plus or minus B. 0, comma plus or minus B. So these are the points that we have: C, S, A, Z, B, L, L dash. These are the coordinates of the points. Okay, now we are going to see equations of the lines. So what are the lines we have? First thing is major axis, next minor axis, next equation of the directrix, next equation of the lattice rectum. Those remembering also very easy to remember. Why? Because if you know these concepts easily, then it is easy to remember those equations are also. Okay, now let us learn those concepts. Okay. Welcome back. So here you see here, first thing what you have to learn in this concept is all the lines. First line is major axis. Already I told what is major axis. So it is an axis which passes through the foci and which passes through the foci, S and S dash. That is called major axis. Okay now, if it passes, if foci are on the y axis, S and S dash, then BB dash will be the major axis. For that also we have an equation. I will explain it later. Now first one, equation of major axis. Major axis means AA dash or ZZ dash. This equation is nothing but, you see here, major axis is nothing but x axis. Major axis here is nothing but x axis. What is the equation of x axis? Y is equal to 0. That is the equation of the major axis. Second thing what you have to learn is minor axis. Minor axis means equation of minor axis. What is here minor axis? BB dash, nothing but y axis. That is BB dash, it is nothing but y axis. What is the equation of y axis? X is equal to 0. X is equal to 0. So we got the equation of major axis and we got the equation of minor axis. Very nice. Next we are going to see the equation of the directrix. Equation of the third one we are going to see equation of the directrixes. Directrix is singular, directrices is plural. Observe here how to get here. Now what are the coordinates of Z and Z dash? So this is given as plus or minus AE comma 0. Plus or minus AE comma 0. So here y coordinate is 0 plus or minus AE comma 0. Therefore, the equation of the directrix is x is equal to plus or minus, here A by E, plus or minus A by E. Therefore, the equation of the directrix is x is equal to plus or minus A by E. That is to the right side x is equal to plus A by E, to the left side x is equal to minus A by E. Okay now, next one. Fourth one, equation of the lattice rectum. Equation of the lattice rectum. See here, the lattice rectum passes through the focus, S also. What are the coordinates of S? So this is equal to AE comma 0. This is a AE comma B square by E. So this is a AE comma minus B square by E. What do you observe here? Here S is AE comma 0, L is AE comma B square by E. Here L dash is AE comma minus B square B. What do you observe? What are the common property that we observe? AE, x coordinate is AE. Therefore, the equation of the directrix is x is equal to plus or minus AE. Equation of the lattice rectums is nothing but x is equal to plus or minus AE. So, plus AE nothing but LL dash, minus AE nothing but S dash. The lattice rectum which passes through L dash. Okay, any more things are there? So, we got major axis, minor axis, equation of the directrix, equation of the lattice rectum, and everything, all the equations we got. Okay, now next. Our next concept is we are going to see the lengths. What are the lengths we have? The length of major axis, length of minor axis, length of the lattice rectum, and distance between the center to the foci, center to the vertex, center to the directrix. All those things we are going to see now. Okay now? Now in this topic we are going to see the lengths and distances. Lengths and distances. What are the lengths and distances means? First I will find out the lengths. First thing is length of major axis. Major axis means A dash, that means from A to A dash only we call it as major axis. So actually major axis is completely, it will come, complete x axis is called as a major axis. Complete x axis is called a major axis. But coming to the length, we will take the distance between the vertices A and A dash. Distance between the vertices A and A dash. What is a vertex? The definition also I have given. The point of intersection of the conic, whatever may be the conic, with the axis is called, axis of the conic is called the vertex. Here A dash, complete a line passes through A dash is called a major axis, but length, coming to the length, we defined as the distance between the vertices A and A dash. So this is given as 2A, major axis. Second one, length of minor axis. Minor means small. This is given as B dash. So this is the minor axis, B dash. This length is given as 2B, because already in the previous I told, so from C to B length is B, from C to B dash is also length B, B plus B, 2B. Okay, now, right. Third one is length of the latus rectum. So this is given already, L coordinates. What are the coordinates of L? Plus or minus AE comma B square by A. That means from S to L distance is how much? B square by A. Same distance from S to L dash also B square by A. Therefore, it is a 2B square by A. Length of the latus rectum is 2B square by A. So length of major axis, length of minor axis, length of latus rectum. So these lengths are over. Now we are going to see the distances. So up to here lengths are over. Now distances. What are the distance means? From whatever member distance, we will start from the center. We will calculate from the center. First thing is center to the foci. Center to the foci, CS. CS is nothing but AE. Why? Because what are the coordinates of S? AE comma 0. CS is equal to AE. Second one, center to the vertex, CA. CA is nothing but A. Why? Because what are the coordinates of A? A comma 0. Next one is center to the directrix. Center to the directrix, CZ. CZ is nothing but A by E. CZ is nothing but A by E. CZ is nothing but A by E. So CS, CA, CZ. CZ is nothing but A by E. So those are the lengths that we have. Here very important point I am going to say now. After seeing these three values, that is AE, A by E, do you getting any relation between this CS, CA, CZ? See here, CA square is equal to how much? A square. CA square is equal to A square. What is CS into CZ? A by E into A by, sorry, AE into A by E. AE cancel A square. From this what you are getting? What you will get? CA square is equal to CS into CZ. CA square, this CA square is equal to CS into CZ. From this we can say that CS, CA, CZ are in geometric progression. If A, B, C, already we know one concept, in if A, B, C are in GP, geometric progression, then B square is equal to AC. B square is equal to AC. B square is equal to AC means what? CS, CA, CZ are in geometric progression. That means the length from first CS, this CS, CA, CZ, CS, CA, CZ, those three lengths will be in the geometric progression. Very important. One of the important result that we will get from by observing these three results. Okay, now right. And some more properties are also there. So here we have seen that the major axis we have taken as a x-axis. If the major axis if you taken as a y-axis, then what are the vertices, what are the equations, all those things now we are going to see. Before going to the next topic, here I have missed two very important concept, that is I have taken from C center to all the distances. Now what is the distance between the foci? That is again one distance between foci. That is S dash. What is the distance between the foci? So this is from C to S is equal to how much? AE. From C to S dash is also AE, distance we are taking, that is why we will take positive quantities, that is why 2AE. Distance between the foci is 2AE. Now distance between directrix, distance between the foci and the one more thing is also and latus rectum. Latus rectums, distance between the foci and distance between the latus rectums, that is also 2AE. Okay, now distance between directrix, distance between the directrix. So what is the distance between the directrix? So this is equal to x is equal to a by e, this side x is equal to minus a by e. So what is the distance we are taking the positive quantities? That is 2a by e, that is z dash. Distance between the directrix is 2AE. Okay, na? So this also is important. So distance between the foci, distance between the vertices, distance between the directrix, 2a by e. Okay, na? So now we are going to see the horizontal ellipse. Let us see the vertical ellipse. Let us see the vertical ellipse. So we call it as a vertical ellipse. So here x square by a square plus y square by b square is equal to 1. Here a is less than b. So here a is means what? So this distance is a and this length is b. So here a is less than b. Then the equation of this ellipse is x square by a square plus y square by b square is equal to 1. Okay, now what is the equation of this ellipse is over now. So next we are going to see what is the eccentricity. The first thing is a very important thing. Eccentricity is root of b square minus a square by b square. Eccentricity is a root of here a less than b, b is greater 1. That is why b square minus a square by b square. Otherwise you can write it as a e square b square is equal to b square minus a square. This implies a square is equal to b square comma 1 minus e square. This way also you can remember a square is equal to b square into 1 minus e square. Okay, na? That is the thing. All the vertices I am writing in the diagram itself, very easy to remember. The center is 0 comma 0. The foci is 0 comma, this is a BE and this is 0 comma minus BE. Here B and B dash are called vertices, that is this is 0 comma B and this is a 0 comma minus B. A and A dash is called minor axis, this is a comma 0, this is a minus a comma 0. L and L dash are called length of the lattice, endpoints of the lattice rectum. So this is a L and L dash. So this is called there b square by a, here a square by b. So this is a square by b comma b, y coordinate is b. Of course, this is a minus, this side a square by b comma b, a square by b, b comma. Those are the all the vertices are over. Coming to equation of the major axis. So this is the major axis equation, x is equal to 0. Equation of the minor axis. So minor axis means this is a minor axis, that is a y is equal to 0. Very important, I have forgot to write down directrix. So this is a directrix, this is also directrix. So this is directrix is y is equal to plus or minus there a by e there in the previous, now here b by e, therefore it is a b by e plus b by e. So this is y is equal to minus b by e, y is equal to minus b by e. So that is the equations of the directrix. Now coming to lengths, the length of the major axis is 2b, the length of the minor axis is 2a, and the length of the lattice rectum is 2a square by b here, 2a square by b, the length of the lattice rectum 2a square by b. Coming to the distances, distance between C and SC is b, C and distance is BE, C and B, distance between C and the vertex, that is equal to B, and C and Z is equal to B by E. So here also you can observe that CS, CB, CZ, B square is equal to BE into B by E. So, EE cancel B square, that means CS, CB, CZ, these three lengths are in geometric progression. That is one of the important point. And now we are going to see the distances. Distance between the two foci, S and S dash is equal to 2BE. Distance between the two vertices, that means length of the major axis is equal to 2B. Distance between the two directrix, so there B by E, here minus B by E, 2B by E. Distance between the directrix 2B by E. Okay, na? So, these are the major things that we have. In these two models, we have taken center coincides with the origin of the two-dimensional system. If the center does not coincides with the origin, that means, for example, so let us say this is a x-axis and y-axis. For example, this is your parabola, sorry, ellipse. Here your center is shifted to some h comma k. So, actually this is your standard form. From your standard form to your center is shifted to h comma k such that the major axis is parallel to the x-axis. Then all these points increment will come. For x coordinate h increment, for y coordinate k increment will come. So, all those things you will see in the next class. So, until then I hope that you enjoyed today's concept. So, in the next class we will see some more concept. So, until then all the best.